So we've used orbitals to analyze what hybridization center we're dealing with when looking at an atom. Very often we can't think of just atoms, we need to think about molecules and the atoms within the molecule. And when we draw molecules, although each bond is made of orbitals, we need to think about the bond, because that's often what's directly depicted when we draw a molecule. So how does the type and number of bond relate to the hybridization state of a particular atom in a molecule? Well, we can think about 4 single bonds or lone pairs equaling an sp3 hybridized center. So maybe we have 4 single bonds, maybe we have 3 single bonds and 1 lone pair, 2 single bonds, 2 lone pairs, etc., etc. But this will equate to an sp3 hybridized center. This is also described as tetrahedral. In the next case, there are a couple of ways of thinking about the bonds and the number of them. The easiest one to think about is a double bond. How many double bonds? Well, there is 1 double bond attached to that atom if it's an sp2 hybridized center. There's also 2 single bonds, but it's quicker and very often easier to spot the double bond. The double bond will always be drawn on a molecule. Sometimes the single bond, especially if it's attached to a hydrogen, sometimes won't be drawn. It's inferred, it's still there, but this double bond is always drawn, so it's quicker to spot double bonds. So 1 double bond attached to the atom, sp2 hybridized center. This is also called trigonal. Lastly, we can think about an sp hybridized center as having a triple bond attached to it. But this isn't the only case. You can also have 2 double bonds attached to that atom, and it's still an sp hybridized center. This is also called diagonal. Let's see some examples of this. In our first example, we can see that the carbon has 1 line going between it and the next carbon. So that's a single bond right there. But we've also drawn 3 hydrogens. There's no line attaching the hydrogen and the carbon, but we know it must be attached by a single bond. So in total, there are 4 single bonds attached to that carbon. So when we think about the hybridization state, it is an sp3 hybridized center. The next carbon we look at, well, how many double bonds? 1 double bond attached, so it's an sp2 hybridized center. The next carbon, well, that's the partner of the double bond. So how many double bonds attached to that carbon? 1 double bond attached, so sp2 hybridized center. The next molecule, we look at the first carbon, we have 1 double bond attached to it, so it's an sp2 hybridized center. The next atom, carbon, has 1 double bond attached to it, so sp2 center. The next carbon, 1 double bond attached to it, sp2 center. The last carbon, 1 double bond, sp2 hybridized center. Our next molecule is a little unusual. It's called an allene. We'll start off with a simpler part of it. Let's look at this carbon. Here we have 1 double bond attached to the carbon, so it's an sp2 center. The middle carbon, this is the tricky one. So how many double bonds attached to it? Well, there are 2 double bonds attached to it. So it's an sp hybridized center. And lastly, well, 1 double bond attached to this carbon, so it's an sp2 hybridized center. In our next example, we begin to see other atoms beyond carbon and hydrogen. Firstly, we're looking at a carbon. We can see 1 double bond attached to it, so sp2 hybridized center. Next carbon, 1 double bond attached to it, sp2 center. Third carbon, well, 1 double bond attached to it. The double bond is going to an oxygen rather than a carbon, but that doesn't matter. 1 double bond attached to the carbon we're looking at, and so it's an sp2 hybridized center. And lastly, here's a carbon, 4 single bonds attached to it, so it's an sp3 hybridized center. The next molecule we'll consider will actually deal with one of the oxygens directly. So let's start off more simply. Here's a carbon, 4 single bonds attached, sp3 hybridized center. The next carbon has 1 double bond attached, so it's an sp2 hybridized center. And here's the oxygen. So we can see one line drawn between the carbon and the oxygens. That's 1 single bond at least. The oxygen has a hydrogen. It must be attached by a single bond, so there's a second single bond there. It's not drawn, but it's implied. So far nothing's fitting to any of our guidelines. Well, we need to think about lone pairs. How many lone pairs are on this oxygen? There are 2 lone pairs here, and they're critical to being aware of them to work out the hybridization state. So 2 single bonds, 2 lone pairs, well, that's an sp3 hybridization center. Our next molecule is called benzene. And the real benzene is a little different from the way we're depicting it here, but we can still analyze the hybridization center. Let's look at the carbon. How many double bonds attached? 1 double bond attached. So it's an sp2 hybridized center. Next, we're going to switch out one of the carbons in the 6-membered ring and exchange it for a nitrogen. This is pyridine. Now we're going to directly look at the nitrogen. How many double bonds attach to the nitrogen? There's 1 double bond attached to the nitrogen, so therefore it is an sp2 hybridized center. Our next molecule, well, the carbon has 4 single bonds attached to it, so it's an sp3 hybridized center. The oxygen has 2 single bonds and 2 lone pairs, so that also is an sp3 hybridized center. Next, let's have a look at nitrogen in the double bond. So the carbon has 1 double bond attached to it, so it's an sp2 center. The nitrogen also has 1 double bond attached to it, so it's an sp2 center. Finally, let's look at where we run into trouble with these guidelines. Here we're looking at boron trifluoride. We're going to analyze the boron atom. We can see here a p orbital. We draw the p orbital in. The p orbital doesn't have an electron in it. It's what's called an empty p orbital. So it's thin air basically, but chemists find it useful to think of the p orbital because it's implied by virtue of the other single bonds and their positions, but the p orbital doesn't have an electron there. It's a little odd. Okay. There are no double bonds. We don't have 4 single bonds, so we can see the guidelines don't work here. But the way we think about it is there is a p orbital. We also have 3 single bonds. Okay, the p orbital doesn't have an electron in it, but for our purposes right now, we don't worry about that. P orbital, 1 p orbital, 3 single bonds. That's best described by an sp2 hybridized center. And that's what we describe the boron as. It's an sp2 hybridized center.